Welcome to Arduino Made Easy. In this episode, we're going to talk about pin mode, input and input pull-up, digital read, and serial communication. So let's get started with this right now. I'm Tom Kovichak, and this is Tom's Trains and Things. This channel was created to help other modelers who are in need of guidance in pursuing their dream of building a model railroad. And with Arduino, we can light and automate our railroad beyond our dreams so easily. We could even run DCC on it with the Arduino Uno. But that's not what we're going to do. We're going to do it the easy way. I'm going to show you some easy tasks to do on here today on pin mode. Now, last episode we did pin mode output. We did digital write and we did delay. So we're going to add to that and do pin mode in input. And we're going to read those input with the serial monitor, and I'm going to show you how to set that up also. So if you would like to see more videos like this, go ahead and hit that subscribe button. And while you're at it, ding that bell, and that'll notify you whenever I have a new video coming out. And speaking of videos, go ahead and check out my playlist where I have a lot of videos in there categorized for you to find them easily. So check them out in my playlist down below. You can see where it says playlists there. So check that out. So let's get started with this right now. We're going to go over and write some code. Right over here is what we got set up. We have the same two LEDs right here with the same two resistors, but you can see I put two push buttons on there. And the reason I put the two push buttons on there is so I wouldn't have to change these jumpers here, because one is a regular input and the other one is input pull-up. This is input pull-up and this is regular input. And as you can see with the input pull-up, these are both normally open push buttons. Typically with the normally open push button, you have an open circuit, but this one here is controlling this LED that's on. So and I push it and it'll turn it off. That's input pull-up. Now this one over here, this one operates as usual. When it's open, nothing happens. When I press it, the LED comes on. You're going to want to learn this because we're working with buttons and LEDs right now, but we could use anything on an input and anything on an output. So we could use any kind of sensor on an input to operate anything on the output. It doesn't have to be an LED. It could be a motor, it could be a servo, it could be anything that we want. It could be an LCD display. Whatever we want to hook up to this Arduino, we can do it on here, and it's simple to follow. We're going to use push buttons and LEDs today to show you inputs and the effect on the output. So let's get going with this right now. Let's start some coding in here. The first thing we want to do is declare the pins that we're using. So let's get over to this right here so you can see it a little bit better. We'll come over here. Okay, what I have is we're going to start out with integer again, and we're going to call it button push 1 equal to, oops, and I did the colon again. And we'll put the comments in there in a little bit. And we'll do another integer button push, oops, 2 equal 3. Okay, that's on pin 3. Then we're going to have the two LEDs on there. Integer my LED 1 equal 4 or no, equal, yeah, it's on 4. And then int my LED 2 is equal to 5. So let's see if there we go. We can move those things out right there. What we want to do is we're going to take a look at what is happening on the button push 1. Okay, so what we want to do is serial.begin 9600 and a colon. Now what we did with that serial.begin, you'll notice that the serial starts with a capital S. That is completely opposite of what all the other commands are. All the other commands, you start with a small letter and the second word is capitalized. On serial, the serial is capitalized, and whatever command you want to do, begin is telling Arduino that we want to open up the serial port, and the serial port is the same thing right here, your USB. Your USB is actually the serial port, and the 9600 is the baud rate. And I'll show you right here. You want to have okay, board at COM11 is not available. Okay, so let's see what's over here. Port, it's on 5. Okay, now we want to go to serial port. What we want to do is make sure that this right here, the 9600 baud rate, is the same as this right here. If it's not the same, it's not going to work. And there's many that you could choose from, but the default one is 9600, and we're going to keep it there. And this is the serial monitor. And what this is doing, this is showing us the state. Since I already have the code in this right here, you can see when I push the button. Oops, I took the auto scroll off. Okay, now when I push the button, it's going to change. But we'll get into that in a minute. So let's get back to writing this on our sketch. Right after that, okay, we'll put in PinMode, and we're going to use variables on everything. So we're going to use button push 1, and we're going to use INPUT underscore pull up. Now there's a difference between input and input pull up, and I'll get into that in a little bit. And P-U-L-L-U-P, I got an extra letter in there. That's my big fingers there. Okay, and then the next one we'll do PinMode. PinMode BTN push 2, comma, and you'll notice everything is capitalized on there. Now we just used PinMode to identify these two buttons right here. This one is an input pull up, and then this one right here is a regular input. Now I don't know if you could see it on here. Let me move this one wire out of the way. But on the regular input, I have a 10k ohm resistor on there. So one side goes to the 5 volts, and then the other side, which is going to the Arduino, it also, the resistor goes to ground. So we'll get into that a little bit later on. Now let's identify some more components here. Oops. We want to identify the 2 LEDs. Okay, we want those as outputs. Oh man, pin. I forgot the mode. PinMode. Okay. And I'm skipping a bunch of stuff here. All right, PinMode my LED output. Okay. Now, PinMode my LED 2 is also an output. Okay, that's everything in the setup right there. Now it's a good idea to compile this, and then you can find all your mistakes in here. And okay, my LED 1 was not declared. Okay, so what I did, okay, that was wrong right there. So now it compiled. Okay, let me go through this code a little bit. Serial begin 9600. We started up our serial communication there. That's our cable right here going to the computer, so we could use the serial monitor that's built into Arduino IDE to see what our readings are on our inputs right now. Now, PinMode button push 1, I have that is an input pull up. That's this one right here. And then button in PinMode button push 2 is another input. That's this one right here. And we have to put our pull down resistor on there. PinMode LED 1 is an output. That's this one right here. And PinMode LED 2 is an output right here. Now we have our resistors right there, and I think I put 330 ohm resistors on there. That's what we have so far. But now what we want to do is we want to, in our loop, we want to push the button and we want something to happen. And what do we want what do we want to happen? We want to see what the reading is on that push button. So when we push this push button, we want to know what that reading is. So we'll put that into code right now. And we'll come over here and we'll go into the loop. Let's take out a couple of these spaces here. Okay, now integer btn, and we'll go value. That's the value that we want to get from the button push 1, and we'll call that digitalRead, and that's where our digital read comes in. And what our digital read is, normally if we didn't put the variable in there for button push 1, we would put the pin number in there of 2. But since we have a variable, we'll put the btn push1 semicolon. Okay. And then we'll do another one, integer btn value 2 equal digital or ed btn push2. Okay, now we identified the button value from push button 1 by digital read, and the button value 2 from push button or button push 2 as a digital read. Okay, now what we want to do is we want to read the value. I'm going to read the value of the first button, and that's the pull up, the one on input pull up. So what we're going to do is serial, and we're going to put in print print line. So whenever it prints out on the serial monitor, after every entry, it's going to do a carriage return and go to the next line. If we left out the ln at the end of that, it would read it all in a row like you would write a word, and it's kind of hard to read that way if you're just looking at a bunch of ones and a bunch of zeros. But anyway, we'll put print line, and then what do we want to read? We want to read the button value. And what we'll do is we'll delay it. There's our friend delay. We'll delay it 250 milliseconds so we can read it. And we'll put our semicolon in there. Now, I'm going to upload this to the, okay. I'm going to upload this sketch to the Arduino. Okay, we're not going to be blinking any lights right now. We're not going to be blinking any LEDs. We're just going to we're just going to see what the reading is when we press this button right here. So we'll come over here, and well, first of all, we'll make sure that everything's okay. Okay, serial print print. Okay, right there. I didn't capitalize that. Okay, we'll do that again. It caught my mistake. All right, let's see. Oh, we're good to go now. Now we'll upload it. Okay, and you'll notice that this stopped blinking right here. That's because we don't have the command in there. We just have, we want to see what the button value is. So we'll turn the serial monitor on, and the button monitor, or the button, is high. And the reason it's high is because it's an input pull-up. So when we press the button, this will turn to 0. And we let go, and it's back to 1. We push it, it's 0. Now, why do we want to know something like that? This is just the button right now. But any component that we hook up to here, whether it's digital with the high or low, or analog where you could adjust 0 volts to 5 volts on your items, you want to know what that is. You want to be able to experiment with it. You want to know what the ideal setting is, so you could write code for it to get it to work properly. Say you had a little sensor in there. Now going back to the blinker, the crossing signal. Say you want to put a sensor in the track, and when your train goes over top of the sensor, it changes resistance. Well, you want to know what that resistance is when you cover up that sensor. So you're going to put that in the code, so when it gets there, then you could put it in the code of what to do. You want those crossing lights to flash, and you want the arm to come down. Okay, now that is in the analog, and that's going to be in next week's lesson. But right now we're just doing the digital. And the reason I'm doing the digital is because this is the easiest way to show you how to get this up onto the serial monitor and how to read a value on what you're doing. Okay, so let's go and put our entire sketch in here now. Okay, digitRead. ALWRIT, digital write my LED 1, comma, BTE, BALUE. Okay, what we're telling it to do right there, digital write, we want my LED to respond to the value of button value, which is whatever the value is of button push 1, which is right here. See, this is integer button value right there, and we have the button value right there. So button value is equal to digital read. We're reading the pin button push 1, which is pin 2. So whatever happens on pin 2, that's going to control the LED here. And we'll do the same thing with LED 2, and we'll do it this way. And we'll just change this right here to 2, and we'll change button value, which is push button 2, to button value 2. We'll put a 2 right there, and we should be good to go right here, and we'll compile that. And that is good. So let's upload this and see what happens now. Now this light will come back on right here. See that? And then when we push button 1, which is open right now, but because it's input pull up, it's actually closed and causing this LED to come on. So when we push it, the LED is going to go off. Now, since we have a pull down resistor on this one here, this is just a regular input, button 2, it's normally open. And when we push it, it's going to turn my LED 2 on. So that's as easy as that. Just 2 push buttons on there, 2 ways that you could operate an input. One just a plain input, and one input pull up. With the plain input, you need to put a resistor on there so you could have a pull down resistor in the circuit for digital, not analog. Analog we're going to talk about next week, and we'll get into some really good stuff with the analog. But anyway, this is what it is here. The 2 push buttons. 1 push button turns the light off, and 1 push button turns the light on. And so if I push that one, both lights are out. If I push this one, both lights are on. So it's as easy as that. Now, let's go back and identify everything that was on there. Okay, button push 1 is on pin 2, button push 2 is on pin 3, my LED on pin 4, my LED 2 on pin 5. So we got 2, 3, 4, and 5 on there. Okay, we have ground going to the ground bus, and then we have plus 5 volts going to the plus rail on our breadboard. I'll put a fritzing diagram up of what we did today right at the end of this video. That's our lesson with inputs and how to read the inputs. Now on the next one, when we do the analog inputs, we'll go a little bit further into the serial communication on how to use that to get input from the user to turn something on. So wait for that next week. Here is the finished code with the comments in it. I told you I'd put the comments in there later. It was just to make it a little bit easier to follow without putting all the comments in there, but you could see the comments in there now. Now here comes the fritzing diagram. All right, here's the fritzing diagram. As you can see on here, this is our 1 push button that goes to number 2, and then this side over here goes to the, oops, I got this one on the wrong side. All right, now we got it going. Okay, I made a mistake on that one, put it on the wrong pin over there. This is the push button, the pull-up input pull-up. Pin number 3 with the blue wire is hooked to this side of the push button and the resistor that goes to the ground. And over here, that's where you get your power. And when you push that push button, that turns on this light. This light is on when this push button is left alone. When you push this push button, this light goes off. Just the opposite of what you would normally think it does. That's because this is a input pull-up right here. So that's the fritzing diagram. Let me see if I can get this line. There we go. Get that a little bit straighter right there. And I'll take a picture of this so we can put it up on my web page, and we'll be good to go with this. So that's all we have for right now. I hope you learned something on there. I hope you pause it and then try it out for yourself instead of just trying to copy the code that I have listed. And I have it listed at tomstrainsandthings.com/Arduino. The code will be there on that page there. This new code will be there up on when this video goes live. But anyway, get in the habit of typing the stuff in. And when you type in a couple of lines, go ahead and compile it to see if everything is okay. And if you misspelled something, or you forgot to put a semicolon, or you forgot to put a parentheses in there somewhere, it's going to tell you it. So you don't have to go do 30 lines of code and then compile it and then come up with 10 lines. Maybe do 5 or 6, 7 lines at a time, and then check to see if it's okay, and then keep on going down like that. It's a little bit easier, and you won't come up with so many mistakes, because believe me, I make a lot of typing mistakes because of these clunky fingers here, and I'm always hitting the wrong keys. Like every time that I wanted to hit an enter, I hit the plus key instead. It happens, and that's what the compiler is for, to check whatever you have to make sure that the Arduino is going to be able to read it. That's it for today. We'll see you next time, and I hope you enjoy watching Arduino Made Easy. I hope I made it a little bit easier for you. So we'll see you.